Hello friends. In our earlier video I have already discussed about enzyme kinetics for competitive inhibition. Now the non-competitive and uncompetitive inhibition was left. These two type of inhibitions we will find it their rate expression. Okay, earlier I have already discussed about competitive. In that competitive inhibition everything actually is similar, but what we will see in case of non-competitive inhibition is that suppose let us consider, suppose this is a enzyme. Okay, everything is actually similar, only just there is a slight difference in case of non-competitive inhibition. So suppose we consider this is a enzyme, then this is a active site, or we can say it is a binding site. And as we know that substrate is going to bind in that active site of the enzyme. But in case of non-competitive inhibition, what will happen, that we have inhibitor which is I. So this inhibitor, this in case of competitive part we have seen that there is a competition between the substrate and inhibitor, whether who will bind in the active site of the enzyme. But in case of the non-competitive, what happens, inhibitor is not going to bind in the active site. It will bind in the site which is different from the active site. That means it will bind here, which is called as allosteric site. It is known as allosteric site, and this allosteric site is different from those of the active site. It is not an active site. Okay, so substrate, so what happens, the inhibitor is going to bind in the side of the enzyme which is not active site. It means the other side of the enzyme, that means which is known as allosteric site. So in that site, if it binds, then what we are going to see is that there is a change in conformation of enzyme. Suppose here the inhibitor has bind in the allosteric site, then what we are going to see is that this substrate which is we have written as, so this substrate will be unable to bind in this active site. It will not be able to bind in the active site. Why it will not be able to bind in the active site? Because you can see that there is change in the conformation, the shape of the enzyme has changed. So this happens when the inhibitor binds in the allosteric site, the site which is not active site, but it is also a site of the enzyme. Now as soon as the inhibitor binds in this allosteric site, this substrate will not be able to bind in the active site of this enzyme, because there is change in the conformation. Okay, and as a result there will be no any reaction. So now let us see there. Now we will consider again the equilibrium reaction, as we have already considered in case of the competitive inhibition. So similarly here also we have the same type of equilibrium reaction. So suppose if E is the enzyme and S is the substrate, then we have K1 for forward reaction rate constant and K minus 1 for backward reaction. It will give ES, and ES gives product. That was we have already seen. And also here we have inhibitor, which was K3 and K minus 3 EI. Okay, so this was what we discussed in case of competitive inhibition. This is the equilibrium reaction which we have already discussed in the competitive inhibition. But in case of non-competitive inhibition, what happens to this ES complex, the inhibitor can bind. Okay, this inhibitor can bind to the complex of this ES. Okay, so it will give us another type of complex, that means ESI complex. So there is a formation of ESI complex in case of non-competitive inhibition. And in competitive inhibition, if we want to increase the binding of the substrate in the active site of the enzyme, then what we need to do, we need to just increase the concentration of the substrate. But in case of this non-competitive inhibition, even if we increase the concentration of the substrate, there will be no any effect, because the inhibitor is not in direct competition with the substrate. Okay, it is not in direct competition with the substrate. So for this reason, what happens, even if we increase the concentration of the substrate, there will be no any change. Okay, because increasing the substrate level will not be able to mitigate the inhibitor's effect, because it is not in direct competition with the inhibitor. The inhibitor is not in direct competition with the substrate because it is a non-competitive inhibition. So similarly, there is the formation of ESI complex, and the rate constant can be this one, K minus 3. And similarly, here also the substrate can bind to this EI complex, and it can give this rate constant will be similar. Okay, K1 and K minus 1, it can give ESI complex. So in case of the non-competitive inhibition, what you can see is that there is a new complex formation, that means ESI complex. So now if we see the rate expression, if we as we know that the rate, as I've already discussed, that rate is equal to K2 concentration of ES, and the total concentration of the enzyme in this case will be concentration of enzyme plus concentration of ES plus concentration of enzyme and inhibitor complex, and then plus concentration of ESI complex. So you can see the new term here, that means ESI complex will also be added in the total concentration of enzyme. And in earlier video, for the competitive inhibition, I have derived the value for E concentration and for EI concentration. So I will not derive it again. I will directly write their values. As we know that in earlier video we got the value of ES Km, which is Michaelis constant concentration of ES by concentration of substrate. This was let us give equation number, okay, let it be equation number 2, and this is equation number 3. And also for EI complex, we have Km concentration of ES concentration of I by Ki concentration of substrate, that is equation number 4. Okay, and this Ki means what? Ki is equal to, is the dissociation constant for the inhibitor, K minus 3 by K3. Okay, so these values, how we have obtained the values for concentration of enzyme and concentration of EI complex. So this value can be seen from my earlier video. You can easily know how we get these values. Okay, because I have already derived these values, but you can also derive it, that means by using the steady state approximation, because steady state approximation is what we required to get the values for these intermediates. Now I will here derive the value of intermediate for this one, ESI intermediate. So for this the same process will be followed. It means the steady state approximation will be, so the change in the concentration of ESI complex can be written as, now we can see that from here we can directly see that it is for forward direction we have K3, for backward direction we have K minus 3. No, so we are going to do for forward direction it is K3, that is positive K3, and concentration of ES enzyme and substrate complex, concentration of ES, and also concentration of I, sorry, in this case we have again concentration of I. Okay, because I is also taking part in formation of ESI. Okay, so in case of backward direction we have minus K minus 3 concentration of this ESI. ESI, concentration of ESI, and this will be equal to 0. So this implies K3 concentration of ES, concentration of I is equal to, this can be shifted towards the right hand side, so we are going to get this value. So here we have then concentration of ESI is equal to, we can write K3 concentration of ES, concentration of I by concentration of K minus 3. So now what we are going to do is that we are going to divide the numerator as well as denominator by K3. Okay, so if we divide the numerator and denominator by K3, then what we are going to get, concentration of ESI is equal to, so K3 by K3 will be cancelled out, so it will be just ES, and then concentration of I by, and this will be K minus 3 by K3, and this is what, this is Ki, so we can write it Ki, concentration of ES, concentration of I by Ki. This will be equation number 5. Now what we are going to do is, we will put the values of all these intermediates in this equation number 2. So if we put the value of concentration of this E, concentration of EI, and ES will be remain as it is. Okay, like in competitive inhibition I have discussed that ES will be taken common from all this expression, and for ESI we can again get the concentration of ES as the we can get its value, so we can take common ultimately. So concentration of E naught is equal to, as we know, it is concentration of E plus concentration of ES, concentration of EI plus concentration of ESI. So concentration of E means we have Km concentration of ES by concentration of substrate S, and ES will remain as it is, plus concentration of Ki, we have the concentration of EI, we have Km concentration of ES, Km concentration of ES, concentration of I by Ki, and concentration of substrate. And similarly we are going to put the value for this ES. Okay, this ES value we are going to put, that means concentration of ESI, sorry, the value of ESI we are going to put here. So concentration of ES, concentration of I by Ki. So from all this term, if we take ES common, concentration of ES will be taken common, then we have Km concentration of S plus here 1 concentration of I by Ki concentration of substrate, plus, and here also ES will be taken common, concentration of I by Ki. So that is what we are getting its value. So again we will take LCM Ki concentration of substrate, then it will be Km Ki plus Ki concentration of substrate plus Km concentration of I plus concentration of I and concentration of S. So we will do cross multiply, then we are going to get the value of ES. So value of ES, we can see that it is E naught Ki concentration of substrate and by Km Ki plus Ki concentration of substrate plus Km concentration of I plus concentration of I, concentration of S. And from equation, that means equation number 1, what we have seen already in equation number 1, that rate is equal to K2 concentration of ES. So this value of ES, the value of this ES will be put in the equation number 1. So we are going to get, this implies concentration of rate is equal to K2 concentration of ES, no? So in this we will put the value of the ES. So we are going to get K2 concentration of E naught, and then Ki concentration of substrate, Km Ki plus Ki concentration of substrate, plus Km concentration of I plus concentration of I concentration of substrate. Now as I have discussed earlier in my earlier video that K2 E naught is Bmax, that means the maximum velocity for the formation of the product. So that is equal to Bmax concentration of the substrate by, and this we have the same Km, oh sorry, we have again here Ki also, no? So here Ki also, Km Ki plus Ki concentration of substrate plus Km concentration of I plus concentration of I plus concentration of substrate. So now what we shall do, actually this is the rate. Now we shall do is that we can divide the numerator and denominator by this Ki concentration of S. So if we divide the concentration of numerator and denominator by concentration of, okay, if we divide it, similarly here also we have Km Ki, then it will be divided by Ki concentration of S. So similarly for this also we have Ki concentration of S will be divided by Ki concentration of S. So again this will be divided Km concentration of I by Ki concentration of S plus here concentration of I concentration of S, which will be divided by Ki concentration of S. So we can just cut it, Ki will be cancelled out, this will be cancelled out, and then here this substrate will be cancelled out. So at the result, at the end we are going to get rate is equal to Bmax by, we have Km concentration of substrate plus 1 plus Km concentration of I by Ki concentration of substrate, and plus here on we have Ki by, oh sorry, concentration of I by Ki. So that we are going to get. So from these two expression, this and this, we will take common concentration of Km by concentration of, Km by concentration of S. Rate is equal to Bmax by, from this we are going to take these two, that means Km by concentration of S, we will take common. Okay, so if we take common Km concentration of the substrate, if we going to take common, then we will see that from here it will be 1 plus Km and concentration of I by Ki, concentration of I by Ki, and similarly we can see this I plus this concentration of I by Ki, it is already there, no? So plus 1 plus I concentration of I by Ki. So now from these both terms we will take this term common, rate is equal to Bmax by 1 plus concentration of I by Ki we are going to take common. Then we shall get Km by concentration of substrate plus 1. So this is actually the rate equation for the non-competitive inhibition. That is the equation for the non-competitive inhibition. Now we will see the next, that means uncompetitive inhibition. In uncompetitive inhibition, what happens, the inhibitor is going to uncompetitive inhibition. In this uncompetitive inhibition, what is going to happen is that we know this equation, E plus S K1 K minus 1, it will give concentration of ES, and then this will give K product. In case of uncompetitive inhibition, what we are going to see is that the inhibitor is binding only to this complex, that means ES complex. It will not bind to any other complex. It will just bind to ES complex. We have to remember this one. In case of uncompetitive inhibition, the inhibitor is going to bind to ES complex only. So if it binds to ES complex only, then we have K3 K minus 3, it will form concentration ESI complex. ESI complex it will form. So now we know the value of ESI now, and the rate is same, that means K2 concentration of ES, and we know that E not total enzyme will be in this case concentration of E plus concentration of ES and plus concentration of ESI only. Okay, there is no any concentration of there is no any EI complex. EI complex is not formed in case of uncompetitive inhibition. What happens? Only the inhibitor is going to bind to the ES complex only. It will not bind to any other complex. So same way, the value for this concentration of E, concentration of ESI will be, we can put it. So concentration of E means we have Km, concentration of ES, concentration of substrate S, so this will be ES only, and plus concentration of ESI, it was concentration of ES, concentration of I by Ki. This one, concentration of ES, concentration of I by Ki. So directly we can do it by taking common. We are going to get Km concentration of substrate plus 1 plus concentration of I by Ki. That is the total concentration of enzyme, and then we can easily do this one if we know the value for ESI. If we know the value of ESI, there is no any problem to find out the rate expression for non-competitive as well as uncompetitive inhibition. Easily we can derive it because they are very much related to each other. Okay, now here Km Ki plus Ki concentration of substrate and plus this will be concentration of I by concentration of S. So here concentration of E naught, so it will imply us that ES complex will have, its value will be E naught Ki concentration of substrate, and then Km Ki plus Ki concentration of substrate plus I and concentration of substrate. Now this value of ES we are going to put again in this red expression. So same way, this K2 E naught means it is a Bmax. So red is equal to Bmax Ki concentration of S by, we have Km Ki plus Ki concentration of substrate plus concentration of I plus concentration of S. Then again we are going to divide numerator and denominator by Ki concentration of substrate. So if we divide, then we are going to get Bmax. This will be cancelled out because we are dividing numerator and denominator by Ki concentration of S. So in this this expression, Ki will be cancelled out. Then there will be Km by concentration of S, Km by concentration of S, and then plus here it will be 1 only because Ki concentration of S is divided by the same term. Then here it will be 1, and in this case we will have I because SS will be cancelled out, concentration of I by Ki, concentration of I by Ki. So yeah, so this is the red expression. Okay, this is the red expression for uncompetitive inhibition. So in case of uncompetitive inhibition, we have to just remember that what we will need to remember, that is the inhibitor is not going to bind to any other things. That means it will be just binding to the ES complex. Okay, to this ES complex only the inhibitor is going to bind, and it will form ESI complex. So by this way we can derive the red expression for non-competitive and uncompetitive inhibition. Okay, thank you.